go ahead and get started. All right, so please make sure that you've downloaded and installed Python so you can follow along. Coding, just like watching someone code is great, but being able to do it is even better. So if you were able to install it and can follow along, that'd be really fantastic. This workshop is intended for beginners, so if you have no prior experience with programming, that's totally fine. We'll cover some basics and then move on to more difficult stuff, but by the end of it, you'll be Python pro, I'm sure of it. We'll be covering programming basics, Python syntax, functions using libraries, and some more explorations. So yeah, just a couple notes before we start. Please mute your microphones. If you don't mute microphones, there's a lot of background noise and it gets confusing. If you have a problem with your code, go ahead and click on participants and then click the no button, and one of us will come help you out with that. If one of us doesn't get to you, please just message us privately in the Zoom chat and we'll try to get to you as soon as we can. If you think that your problem might be something that other people are facing as well, go ahead and put it in the Zoom group chat and we'll try to figure it out from there. If you have a general question or comment, use the raise hand button. Again, that's under the participants tab. And then we'll call on you and we'll try to answer those questions. Yeah, anybody have any questions about anything? Cool. So go ahead and let's welcome Nate Browne, our wonderful workshop person.
Oh, don't hype me up too much. That makes me nervous. All right. How's it going, everyone? So my name's Nate, fourth year CS and Cog-Sci major at UCSD. Well, I guess not at UCSD anymore. Sad.
Aww.
But so yeah, I was asked by Jared to help with this. So I'll be trying to go through some basics of Python. Hopefully by the end of this, you all maybe it won't be super Python fluent, but you'll be able to get enough out of it that you'll be able to look things up on your own, go further from there. Read Python code that you see, stuff like that. So there's also like a thing I'll send at the end, which is a nice, pretty much like a guide, further reading you can do that's like another introduction that I'll send at the end if you want to go through that as well. All right, so some basics of Python to start off with. So as a programming language goes, Python is a very interesting language in that it is very user-friendly, very readable, very nice to use, but at the same time, depending on your level of introduction with other types of programming languages, stuff like that, it might be kind of a culture shock. So to start off, to throw out some fancy phrases out there just to get them all out of the way, Python is dynamic, interpreted, and it is run usually through an interpreter. What that generally means in terms of stuff we don't care about for the sake of the workshop, but just for clarity's sake, is that Python code is not run through a compiler. So when you write something in Python, until that line gets run, you don't know if it works or not. This is bad in the sense that it means that you can't check your programs ahead of time, like in some other languages, but it's nice because it means that if you ever have a question of what does this do, you can just try it, which is a pretty nice feature. So before we get into that though, first thing we want to do is make sure everyone has Python installed. So for that, for the installation for Python, there are a couple potential options depending on the system you have. Option one is always to go to Python, I believe it's python.org. Yes, go to python.org. There'll be an installation button there. You download it, install it like normal. It's pretty nice. Option two is if you are more into data science or machine learning type stuff, you can go to this website called Anacondas. So I will put these links right now in the chat. Let me put it out right there. Great, there it is. Okay, so here's option two. Anaconda is it's like an entire environment which comes with a whole bunch of tools used in data science and a bunch of other stuff like that, which comes with Python, comes with a bunch of libraries, comes with some other stuff too, some commonly used stuff. So it's pretty nice as an all-in-one type of thing. Option three, the option if you have a Mac, I recommend this option, is to install a couple things. One, you go to this website, homebrew, brew.sh. There's a command on there. Type that into your terminal, press enter, let it run. And then afterwards, you just type brew install Python 3. That option, I think, is nice if you have a Mac. It's the easiest one. If you don't have a Mac, don't worry about it. The official installation is very useful for Windows. Cool. All right, so I'm going to assume that you all are either going to follow along or are following along in your own terminals, which will make this nice and interactive. But if not, that is fine too. But Python is the type of language I think that it's easiest to learn by doing, because there's a lot of stuff in it that's kind of quirky, and it helps to just get experience with it as you go. So with that said, let's get started. Real quick, actually, before we do that, one quick note you should be aware of if you become a Python programmer is that there are two versions of Python that exist, like two, I guess, branches. Branch 1 is called Python 2. Branch 1 is Python, the other one's branch on. Sorry, the other branch is called Python 3. Python 2 is end of life. They no longer support it. There's no more releases for it. Chances are you shouldn't be using stuff that's Python 2 anyway. It has been deprecated. Python 3 is the current version, and they're working on 4, which is just an extension of 3, not like a huge shift. The big differences between the two, there's some differences, some syntactic differences, some function names have been changed, stuff like that. But in general, since we're learning Python 3, it won't make too much of a difference. But it's just something to be aware of if you see some code on the internet that might be Python 2, to know, oh, this function, or to at least recognize this stuff is different. I need to look out for this if I want to run this, stuff like that. Cool. Any questions about that so far? Fantastic. Okay, yes, that is a good point. So the question is that if when you type Python, you get version 2.7.16. That is because a lot of systems have their own pre-installed version of Python, which is necessary for certain tools and libraries on the computer that you don't touch to run. That version is fine to use, except it's not going to be up to date and supported. So I'd recommend you do install Python 3 instead of Python 2. You can still do most of this using 2, but I'd still recommend using 3 just because it's the up-to-date version. Cool. Good question, though. All right, so getting started. The nice thing with Python is that, like we kind of mentioned, you can just get stuff up and running whenever you want, just as easy as typing in your terminal. So I'm going to go to the share screen mode, and then we'll get started from there. Just give me 1 sec to fire up my terminal, and then we'll get into some stuff like that. Cool. Any other, how's the installation going? Is everybody installed? We have some time to wait to make sure people have stuff installed, so we can actually hold on a sec for that. So is everyone good to go with install? All right, I will take the silence as a yes, that everyone's good to go.
I got a question. If I used Anaconda, how do I open up the terminal?
Great question. So if you use Anacondas, it will actually still work the same way. So you can still open your terminal. Presumably you're on a Mac potentially?
No, Windows.
Oh, no, okay, on Windows. So then you can run the Anaconda program. And then if you want to, I think the easiest thing to do would be to fire up, there's a program in there called Jupyter, Jupyter.
Yeah. See it.
And then when you have that coming up, you'll have like this window, which is a basically like interactive Python session. It looks a little different, but you can type your stuff in and then press the run button at the top, and it will, you'll be able to follow along from there.
Got it.
Cool.
Do I need Anaconda if I'm on Windows?
You don't need it. It's nice because it comes with a lot of stuff, but it also comes with its own version of some stuff. So you don't need it. It's just if you prefer and if you want to get into data science, it's pretty nice.
Oh, okay.
Yeah. Okay. We have a question. I ran the command on terminal and then typed. Okay. So when you go to that brew.sh website, there's that command that I pasted in the chat earlier. This one, paste it. Type that in, just copy paste that into your terminal. It's going to prompt you for some stuff. It's going to ask for your password. Type that in, press enter. Then you can run the brew install command. So Sammer, help. Let me know if that helps. Yes, you could also just run it from the website if you want to. You can just download it off of python.org as well. Is Python 3 backwards compatible? With what? Most Python 3 code and 2 code will, it's mostly the same, so it will run with each other, but there are some stuff that will change that will either not work from 2 to 3. Oh, yeah. So there's some stuff that will not run if you have from 2 to 3. Other stuff will run. Others, like for example, I guess one quick example is that one function in 2 was called xrange that got changed to range in 3, and how input in 2 works different than input in 3. Which version are we using? You can, if you, I think for downloading, you can download just the most recent version off the website should work. So if you go to the Python website, can't type anything. Okay. Okay. Okay, we will keep going, and then if people are still stuck with getting stuff to run, can you repeat how to open up a terminal? Yes. So to open up a terminal, if you were using the Anaconda's version, if you're using Windows, what you'll need to do is just open the Anaconda's app that installs, and then click the Jupyter thing, Jupyter, and that will give you an interactive session that you can use that will be close enough to what we're doing. If you install it on Mac and using Anacondas, or Anacondas, then you can open your terminal as before, and then type Python 3 with no space, and then you should be good. Cool. Good to see people getting stuff working. So let's keep going. Python version of Python, a different interpreter. Yes, if it's 3. Python 2 will have certain things that were different. I can point out some differences as we go between 3 and 2, if that helps. 3.7, yeah, that works just fine. I think I'm running 3.7 as well. Yeah, running 3.7 as well. Yeah, you can run it online through your browser as well if you find an online version too. Cool, so let's get going. I'm gonna share my screen with you now. Cool, all right. Can you guys see my screen? Hopefully. Yes, great. All right, so let's get started. First off, we're just gonna fire up, I'm just gonna start up Python 3 like that. And then we have our nice interpreter. So let's get started with some of the basics, right? One thing to note with Python as a language is that since it has its nature of just being an interpreted language, this screen you see, the interpreter here on the screen, is what allows you to interact with it at a base level. We'll get into how you run it separately, but just as a base level, this is how you interact with it. I also realize I can't really see the chat if I do this. Unmute yourself and then just say something if you have a question. But if you feel comfortable with that, otherwise I'll look back at the chat. Okay, so first things first. What we're gonna do is start with some of the basics of just general programming and going from there. So first things first, most programming languages effectively function as, I guess, calculators is a way of starting it off. So this interpreter is no different. You can do your standard type of operations you would expect, like plus, right? 3 plus 5, it tells you it's 8. Or 5 times 9, you get 45, right? You can do minus, all the usual type of stuff, right? Type of stuff you'd expect. You can do division too. Like let's say 4 divided by 3. Get that. Kill that. Cool. Now, crucially, I guess an interesting thing to note is that Python also lets you do Other types of operations besides just the standard addition, subtraction, multiply, divide, right? There's also what's known as integer division, or AKA flooring. So you could say for 2/3, you get 1 without the rest of it. So it handles decimals, it handles regular numbers, whatever you want, right? Python also handles strings, right? Where strings are wrapped in quotes, like that, lets you print stuff. Cool. All of this would be, if we just stopped here, this would be kind of useless as far as things to do, because it's basically no more than a glorified calculator, right? Where it gets more fun is that we can do things with variable assignment as well as functions. So, firstly, the first thing to note with most every programming language is that for most programming languages that exist, equals works slightly differently than what you would expect in terms of math, right? So equals, single equals, does, I guess the best way to say it does assignment, which just means that you take something on the right side of the equal sign and store it on the left side of the equal sign. For instance, if I wanted to make a variable and I wanted it any value, which has a name, which you can store things in, and I want to give it the value, let's say 6, I could say something like variable equals 6, right? It doesn't say anything now. So now if I type variable and get back 6, because what it does is it looks up the value of that name and gives me back what it's holding, right? This also means that your variables can be used in expressions. So I could say variable plus 2, and I'll get 8, right? What's different with Python compared to other languages is that since you don't have to declare types of variables, which means you don't have to say what type of the thing it is, you can reassign it really easily. So now I can say variable equals hello there. When I print it, I get hello there. So now it doesn't equal 3 anymore, right? Cool. So now what's interesting though is that even though you're not seeing it under this hood, you're not seeing it explicitly, under the hood in Python, there's a lot going on to make sure that your expressions make sense. So one of these type of things that you can check is actually the type of your expressions. So for instance, by using the function called type, I can pass in type of whatever I want, and it will tell me what it is. So right now variable is class stir, or I could say type of 5 and I get class int, right? So I can see that 5 is an integer variable, right now is a string, and so on. Cool. Now, what's nice is that Python, yes.
What's a string?
What's a string? Yes, we're about to get to that, but to preface it, a string is just when you put quotes and you have some sort of alphanumeric or really any type of character within those quotes. So when you want to represent input from somebody, it comes in usually as a string, and you can manipulate it in different ways. We'll get to that a little bit more in a little, in actually short little second. But before we get to that, the whole idea with this type thing that we don't see is that if you have things that aren't compatible with each other and you try to do operations that don't make sense, you will end up with problems. For example, if I said variable plus 3, it's going to say, I don't know what that means. And you get an error. Right? Cool. If we try something else, like let's say we don't define something, like I haven't defined just the single letter P, it's going to give me another error and say, I don't know what that means as well, right? So the interpreter gives you direct feedback. You type in something and it gives you back either a response, an answer, or nothing, right? Cool. All right. So for some general I guess some general like Python stuff to note is that Python files, like the type of files you would see, end with .py as their extension. So let's make one. You can call it hello.py. And now I can open this in whatever I want. So for the sake of this, I'm going to open it in my fancy text editor, but you can do this in whatever you want. You can do this in Notepad. You can do this in Microsoft Word if you wanted to. Run this however you want. We're going to open this right here. So here's our file, hello.py. There's currently nothing in it. It doesn't actually have any code in it yet. It doesn't know what it means. But we can add stuff to this now, right? So every Python file.
Sorry, could you repeat that? With the command?
Yes. So to get to this point, what you can do is if you are following along with the terminal, so if you have your terminal open, if you have Jupyter, don't worry about this too much. But if you have a terminal, follow along here. You can go to whatever you want. So you should be in a place where you can see, like if you look at your terminal, shouldn't have anything in it. If you type the word touch, then a space, and then you type the name of the file you want to create. Make sure it ends with .py. You can call it whatever you want, right? Okay, enter. And then once you've done that, you can type ls, and you should see that you'll have a file there, which you can open using whatever you want. One thing I'd recommend you try out is if you have it, try out Notepad. Notepad will be pretty useful if you're on a Windows PC. If you're on a Mac, you can use Microsoft Word. You can use pretty much whatever you want and copy and paste things in. It's up to you. We're not going to use this file for very much. It's just to give you all a quick primer. But we're not going to use this. We're not going to use files very much. We're going to use the interpreter for the majority of this. Because I assume that most of you wouldn't have. Oh, sorry. You should be outside of the interpreter for that. So to leave the interpreter, type a quit with parentheses. But I'm just showing this as a quick example. We'll get out of the interpreter pretty soon, or we'll go back to the interpreter pretty soon because we don't want to stick to the files for now. We can talk about files more near the end, but we're going to stick in the interpreter for now. All right. So just to quickly show you, you can run some stuff. So you can put, actually, no, we'll come back to this. We'll come back to files, actually. Yeah, there's some stuff we have to cover first before we get to here. So we'll go back to the terminal or to the interpreter. All right, so how many of you, just out of curiosity, have seen any programming languages before? And if so, which ones?
C++.
C++, okay.
I've messed with JavaScript a couple times.
JavaScript, okay, cool. Got some good ones. Java, C++, Ruby. Okay, MATLAB, cool. Java, MATLAB. Okay, cool. That's useful because Python, this is where it's going to get a little weird. So for those of you who have seen stuff like Java, C++, JavaScript, Python will look a little funky. If you've seen Ruby or even MATLAB, it'll look a little bit more familiar. But this is going to get a little fun. Python, unlike Java and C++ and a bunch of languages of those types, doesn't use it doesn't use curly braces to denote anything. So if you've seen any Java code, you've probably seen that there's curly braces and semicolons everywhere, right? Python does none of that. No semicolons, no curly braces. Everything in Python is using white space for indentation. This does mean that the amount of spaces you put with things does matter, which is a little weird to get used to, but also makes your code relatively readable. And given Python's very nice I guess, like very nice operators and syntax, it makes it so that your Python code kind of looks like pseudocode to an extent, which is kind of nice. All right. So next up, we will be showing you, oh yeah, actually, yes, we'll go to that. So back in, still having trouble making a folder. Yeah, so I wouldn't worry too much about files. Actually, I think it would be useful to not actually use files, come to think of it, and then come back to it, just because we can introduce them near the end, but we should probably get to more of the basics, I think, of Python before we get into using stuff like that, if that's okay with everyone. So all you still need at the moment is just your interpreter, and you should be good. All right. So continuing on. Yes. Okay. So one thing that's pretty useful with Python, I think, is that in the language itself, built in, there is a very useful function called help. So if you're ever running into something you've never seen before, like let's say there's this function called len, which gives you the length of things, but you want to know how to use it, you can type help and say len, and then you get back this. And it tells you returns the number of items. Or you can even say something like help, and it tells you about how help works, which, you know, maybe you want to know. All right, I'm gonna clear that, restart, clear that and restart. So you don't have to close it every time, I'm just doing that to clear the screen. But yes, so help is a very useful function. It allows you to get help on things, which seems kind of self-explanatory, but it's very useful to be able to see whether or not some function you want to run or some command you're trying out. Oh, how do you get out of help? Good question. Press Q. Just the Q button will take you out of the help page. Great. So with that brief but somewhat quick introduction, we will move on now into some of the parts of the language. Then after we get through some of the language stuff, we will move on into functions and then some other stuff with that. Great. So starting off, first things first, Python strings. So Python's string class is built in. It's called stir. What a string is that it consists of some sequence of characters, doesn't really matter which kinds, enclosed with quotes. Right. So Python, unlike a lot of languages, does not care whether or not you use single or double quotes, as long as you use the same type of quote on both sides. So example, I can say S equals hello there, or I can say S equals hello there. It doesn't care either way, right? But if I said S equals hello there with the mismatching quotes, it will care, right? But it doesn't ultimately care which one you use. All right, cool. You can put strings on multiple lines if you want to, if you're doing this in like a file, but you need a backslash at the end of each line. But that is not too relevant for the interpreter. All right, so the next thing to note is that strings in Python are an immutable object. So what does that mean? All that really means, if something is immutable, is that an immutable object cannot be changed. Once you create a string in Python, you can't change parts of the string, right? You can change, like, you can just modify it in the sense that if I say S equals hi, and then I say S equals hello, S doesn't equal hi anymore, but I can't change the string itself, hi or hello, right? I can show you that now. I can give you an example. So we have S set to hello there. If I try to say S, let's say 0 equals K, you'll see that it says this object does not support assignment, which is basically it's saying you can't modify strings after you've used them, right? So let's reassign S real quick, just to this. All right. So now what's really useful is that strings can be what's called indexed, which just means that you can get a particular part of a string using these braces, right? So your square brackets. So with our string S, like in a lot of languages, sorry for people who have used MATLAB before, but unlike MATLAB, Python starts counting at 0, not at 1. So that just means that if you want to get, let's say, just the H from the string, what would you need to type? Yes. So yes, you can't change a string, you can redefine it. Yes. But with our string here, hello, if I wanted to just get just the H, what would I need to type? Would I use 0, 1, 2, which index? Yes, S0, perfect. So if I say print, let's say S0, I get H, right? Cool. For quick side note, for those of you who are maybe using Python 2, in Python 2, print is not a function, it is a keyword, which just means that if I go to the Python 2 interpreter, I'll just do this really quickly. For those of you who may be using Python 2, if I do the same thing, let's say hello, I can just say print like this without the parentheses. If you're using Python 3 though, which I think most of you would be, if you're using Python 3, you do need the parentheses there. So that is one reason why if you are using some Python 2 code in Python 3, you got to make sure that it checks, that you check for stuff like this. This is just one instance, there'll be more. But that is just one quick side note. Great. Now, what's nice with Python is that it has a mantra, it has this idea that when you do something for one way, it should work the same way for everything, or as many things as possible. Unlike a lot of languages, Python tries to make it such that there are only a few ways to do everything in certain aspects. So for instance, if you want to get the length of a string, there's this function called len, which gives you the length. So I can say len of S, and I get back 5, because there's 5 characters. Pretty nice, right? Now, remember, though, that len, since it gives you 5 characters as a length, which is true. However, since counting starts at 0, if you want to get the last character, that is the length minus 1. That is just a common pattern in Python as well as in Java and other languages. So just something to keep in mind if your first background is MATLAB, or if you haven't programmed at all. Okay. Now, one thing that is very much a gotcha that you all should be at least conscious of is that Python doesn't necessarily disallow you from renaming things. Since it's interpreted and not precompiled, that means that I could technically make a variable called len and assign it to something else, right? And now if I try running len, you notice it's going to say, hey, wait, that's not a function anymore, right? It's because I overwrote the actual function name. So one thing that you should be very careful to do is make sure that you are aware of keywords or other words that you shouldn't be using as variable names. Otherwise, you may run into problems with stuff. All right, so since Python strings aren't mutable, right, they can't be changed, that means that if I take a string and I add something to it, so let's say I say s equals hello, and then I say s plus there, this isn't actually adding anything to s, right? What this is doing is creating a new string and printing it, right? So if I ask what s is, I still just get hello. How do you clear a variable? In the interpreter, there is a way of doing it. The function I believe you run is called, or the keyword is del. But a quick way you can do it is by, if you're using Jupyter, you can just restart the entire kernel, there's like a button at the top. There's like restart and clear all variables or something like that. And then if you're using the interpreter, you can just quit and reopen it, and your variables will be gone.
I got another question.
Yeah, what's up?
So if you're like, right, you wrote hello there and there was a space, would the print function, if you typed in the number that was relevant to the space and hello there, would it just come out as blank?
Yes, good question. So let's take s and let's set it equal to s plus there. So this is some interesting bit of syntax here, but since the equal sign takes the least priority over everything else, this will do this part first and assign it over here, which is not necessarily what you would expect if your background is purely from math. But if you've seen any sort of assignment before in anything, this will look familiar. So now we've reassigned s, right? So now we know that that blank is at spot number 5. So if we say s at 5, we get back a blank, like what you said it would be. Yeah. Any other quick question? Any questions about what we've seen so far with strings? Cool. Okay. Now one thing that is pretty interesting to note, especially if you're used to Java, this is an important distinction, is that the plus sign can do two things mostly. It can do actual addition between numbers, and then as you've seen here, if you put two strings, it concatenates them, right? It makes one string. What it cannot do is add up a string and a number. So if I try to say hello plus 3, let's say like this, it doesn't know what that means, right? So what you have to do is turn the number into a string. And the way you do that is by using the string function, str, and then you pass in whatever you want. Let's say the number 3. Oh, whoops. And you get back a string, right? So I could say hello, oh, whoops, hello plus that, the stir 3, then I get back that, which is what you would expect because it's taking two strings and pushing them together, right? Cool. So in general, for many objects, for many things, if you want to turn it into a string, you do that by using the stir. Or if you want to turn it into an int, you do that with int, which int is just integer, so numbers. Right. Now, if we want to get a little bit more fun, I guess. Yeah, actually, let's actually talk about that. So an interesting thing to note is that Python supports some other fancier types of strings. Most of these you won't have to learn about for a while. This is something I recommend you look up if you start getting more into Python. But there are different types of formats you can use as far as like, let's say we have our variable s. Let's say s equals, I don't know, Python. We could have this type of string known as a format string. There are raw strings, which you put like an R in front of it, and some other types. But that's some stuff I recommend you look up later if you want to get more into more advanced parts of Python. For now, all we need to care about is that you can add two strings together. You can't add a string and a not string. And you can turn things into strings using the stir function. Great. Now, that is kind of the basics of strings. Another thing I forgot to mention is that this square bracket syntax is going to look very familiar because that will come up again with other types of structures we will see in this language, keeping with the theme of keep things consistent. Right. So now we can go through some of these common functions that you can do to a string, right? So you've seen len, which len you give it a string, right? And you get back a length. But there are other functions you can run on a string. And by on, I mean you take your string, let's say string, you put a dot, and then you put the name of a function. Let's say, yeah, actually, yeah. We'll start with the simple one, split. And then you pass, and then you put the arguments in that you need, and you get back some result, right? So this kind of brings us into a quick segue of sorts into another point, which is about functions, right? So we haven't talked about writing functions yet, but the majority of programming involves writing functions and using functions that are already written to accomplish tasks. In general, a good rule of thumb is to know that if you haven't done it, like if you don't need to do it yourself, you shouldn't. If there's a way to do some task that you want that somebody's already done and they've done a good job of, and it does what you want, use that. It'll simplify things. So functions are a way of packaging up things that are convenient or easy to use into things that we can code with, right? So let's introduce some of the more common string functions, right? Functions, the way you use them is that you put a dot and then the name, you put parentheses, and then if required, you put an argument inside the parentheses or multiple arguments inside the parentheses, which allow you then to, with your function, to add things to it and give it some sort of state or context. So let's use string functions for now. We'll go back to our example of string. We can say dot upper. Upper will do probably what you think it does. It gives you back a new string where everything is uppercase. Pretty useful, right? Conversely, let's say we have string lower will give you back a lowercase version. And this will work if you have mixed stuff too. So let's say we have the string, let's say California dot upper gives you back that, right? The entire thing. California dot lower gives you back that, right? So upper and lower. Cool. I'm gonna clear this real quick. Open it up again so it's fresh. Cool. Now another one that may be useful is called strip. And what strip does is it gets rid of any white space, which is just like blanks, at the beginning or end of a string. So if I have, let's say, just a whole bunch of spaces here, and then string, and then a whole bunch of spaces here, and then dot strip, I get back string. Just by itself, right? This is useful because it can be used for cleaning things up or parsing things. If you have some sort of input coming in, you don't know if there's a bunch of spaces or a bunch of stuff you don't want, you can strip it out, right? Pretty nice. Next up, so we got some more functions that you can use, which are quite nice, which are functions that you can use to give you back yes or no answers. So, as an example, there are some functions called isAlpha, isDigit, and isSpace, where you can have some string, like let's say this string, which is all numbers, right? I can say dot isDigit, and it says true. Because every single number here, every single character in the string is a digit. If I were to put, let's say, an A here, I get back false. Right? You can guess then how isAlpha as well and isSpace will work. We're like, this gives you back true, right? And then say like isAlpha gives you back false. Right? Cool. some other functions that may be useful, which we won't go through all of them. Well, we'll talk about all of them. I won't necessarily show all of them. And these aren't an exhaustive list, but these are just a few. Starts with and ends with are a way of checking, as you would probably guess, if a string starts or ends with a specific character or sequence of characters. So like string that starts with S, we'll say true. ST would say true. STI would say false, right? Or string dot ends with G would say true, but GZ would say false, or whatever else. Right? Find, you can guess what this would do. It searches for another string within a string. So string .ng, what it does is when it finds it, it gives you back the index where it found it, in this case, index 3. Or if it can't find it, it gives you back -1, right? So if it finds it, it tells you where it starts. If it can't find it, it returns -1. So you can use this to check if some input you have or whatever else has some sort of pattern that you're looking for, right? There's also replace, which kind of does what you may think. Like let's say we have string dot replace. Let's replace str with bl. Yeah. So this will take our string called string, and it will replace this pattern with this pattern, right? And it does. If it can't find it, like let's say we try to replace zzz, it will just return back the original string, right? A useful one is called split. So let's say we have this fun string here with a bunch of dots in it. And then to avoid retyping this, I'm going to save this into a variable, call it s. Okay. So if I print s, we have this. What the split function does is it allows you to split your string on a given substring, and it returns to you a structure which we're going to talk about next called lists, right? So we can say s.split on the dot, and we get back this, which is a list of every token that matches after each dot, right? We'll talk about the structure that it comes in a bit, but as a primer, that's one of our first Python data structures. And then join does the exact opposite. So for join, let's say you take a, like the idea is that you have a list of strings. Like let's say we have this. So result is my list of strings, right? I can say a bunch of dashes. Let's say 1, 2, 3, 4, 5 dashes dot join, and then put res, right? What this will do is it will join our stuff together using this string in between as the delimiter, right? If I were to put empty string, which is just 2 quotes next to each other with res, I get this. And if I were to put, let's say, a single space, I would get this. Right? So the join function takes you put some string that you want, you pass it in a list of stuff, and it will combine them using that thing you put as your separator. Right? some very basic functions. So now Python does not have any types for characters specifically. If it has quotes, it is a string in Python. Nothing else, just a string, right? So because of this, Python actually is nice in that, again, in the sake of consistency, it implements a lot of things in a way such that you can easily do what you would expect it to work. Like you could basically do what you want to do directly without having to worry about types. So as a quick, does it only join what was typed? No, not necessarily. What it does is that it will, you give it a list of some sort, which we'll talk about lists in a little bit. You can give it a list of any strings, doesn't matter. And it will join them together, providing it is a list of strings, using whatever you put as your delimiter. All right, so it doesn't have to be what was on the previous line, it can be any list. So I could have a list that says, hi, I want pizza rolls, something like that, right? We could say something like temp space dot join with that list that we just had, and we get back that. Which I don't actually think I want pizza rolls at the moment. I don't know why I typed that, but it's fine. Nice quotation. Yes, the prequels are a treasure. All right, cool. So now we can get to a little bit, actually, before we do that, we're almost done with strings. So we're not done with, but we're gonna move on, from strings in a little bit. All right, cool. So string. So one more thing to talk about with strings is this thing called slicing. The idea behind slicing is that you can take your string, say hello, right? Is that you can use a slice to refer to subpart, to like a portion of a sequence, right? Usually strings and lists, but other types too. So the syntax generally is that you have your variable name, a colon, and then you have a number, or your variable name, sorry, bracket, number, a colon, a number of some sort. Doesn't matter what these numbers are, right? What happens is that what you end up with is that you end up with a sequence that takes in your first number, inclusive, and your second number, exclusive, right? So if I said 1, like let's say S1, 3, you end up with S from 1 up to S at 2, right? Because it doesn't include 3. Right, so as an example, our string here is called S. If I said S at 1 to 4, what do I end up with? L, yes, you end up with just ELL. Good. A quick bit of syntax, if you don't put one of the indices, like let's say I don't put an index here, it will assume, if you don't put it at the beginning, it assumes you want to start at the beginning. If you don't put an index at the end, it assumes you want to go to the end. So if I said S from 1 colon nothing, what do I end up with? Good, yes, hello. If I put, let's say, no numbers at all, what do you end up with? Just the original thing, so the copy, which is cool. And just everyone want to take a guess, what happens if I put an index that's way too big? Yes, if you put an index that's too big, it just stops at the largest index it can find. It won't try to overdo it, right? All right, cool. Yes, this is actually kind of cool. So another thing Python actually has that's a cool feature is that it can do this. It can do negative indexing. So most languages, if you try to use a negative number in your indexing of some sort, you'll end up with an error. But in Python, what it does is that when you see a negative index, it will treat that like you want to go backwards, starting at the end. So if h is, so let me retype the thing to get it at the top of the screen. So we have this again, right? If h is 0, e is 1, this is 2, 3, and 4, right? As you would expect. Then o at the end is -1, and then -2, -3, -4, -5. So we can actually check if s at 0 is equal, which means it's compares at -5, and it says yes, because s at -5 is the h, and s at 0 is the h. Similarly, s at 4 is the o, and s at -1 is the o. Of course, it might not be that useful to try to negative index all the way back to a string, but what it is useful to do is instead of having to say something clunky like s at len of s minus 1 to get to the end of the string, you can just say -1, and you get the same spot. Pretty nice. All right. Another cool thing to note is that with these slices, for any index you give it, if you do something like this, let's say s at :4 plus s from 4 : will give you back the original string. And that's true always. Doesn't matter what the index is. As an example, -4, -4, you get the same string back. Useful. Maybe not the most useful, but it's kind of cool. All right. Next up, we will go back to some general programming concepts, specifically the concept of if statements, because we will use this to introduce some of our next bits of stuff before we get to functions. So as you all have seen, if you've seen programming before, you know what an if statement is. But for those of you who haven't, the idea is that you would be, normally your code executes from top to bottom. It just runs whatever you give it, right? It just does what you say. It would be nice, however, to be able to control when it does something conditionally. Like, I want this to happen if this is true. I want this to happen if this is true. Python gives you a very, it's like most languages, implements this type of control flow, as it's called. And the most basic form is called the if statement. So the idea is that you have the word if, a space, no parentheses, and then you can type some condition. This condition must evaluate to a Boolean, meaning it must evaluate to true or false. And then you can do something. So Python, seeing that it doesn't have curly braces and it doesn't have semicolons, it uses colons, regular colons, to differentiate between scoping of stuff. And then it uses white space as well. So as an example, let's say speed equals 55, right? If speed is greater than or equal to 20, and let's say speed is, actually it wouldn't do it like that. Let's say, this is also a little different than Java, but Python actually allows you to do this. Let's say if 20 is less than or equal to speed is less than or equal to 55, then you press enter. Notice that it gives you the 3 dots. That means it's waiting for you to type something. You can press the tab key or press some spaces. Make sure you know how many spaces, though. I'd recommend you just press the tab key. You can then now type something like print speed is reasonable, right? Then we can say else, then put a colon, and then say print speed is unreasonable, or really whatever you want to print, right? Then you press enter twice, and it executes what you said, right? And you can see that since speed is 55, it went to here. 55 is greater than or equal to 20. 55 is less than or equal to 55. So then it printed this message, right? Cool. So in general, the thing to note with if statements is that this must be something that evaluates to either true or false. And then you can chain these together as many as you want. So I could say something like if speed is less than 20, print slow. ELIF, which is else if, right? Speed is greater than or equal to 21, and speed is, let's say, less than 55, print normal, else print fast, and then it runs. Right, so it'll check these statements, and whichever one matches, it will put there. So with the if else's, just remember that else is your catch-all statement, right? It is your catch-all. If you don't put an else, right, then if let's say I don't have an else statement here, so let's have that same thing. So the speed is less than 20, print slow. ELIF 21, speed 55, print normal, right? If I were to stop here, nothing prints because none of these patterns were matched. Does that make sense? All right, any questions about that?
Leave it.
Getting a syntax error after the else. Okay. That may be potentially if you don't put a colon. So always remember to put your colons there. So you need something like if some whatever condition you have, and then a colon. Else, let's say else if or elif, and then a colon, and then else and a colon. Where the dots there are just to say some thing that you want to check. All right. So something to look up if you're curious and want to get more into Python is that there is this quirk of the language, which is kind of, I guess the best way of describing it is that objects in Python have a certain truthiness to them. So what do I mean by truthiness is that there are certain things in Python that will actually correspond to being true or false, even if they don't equal true or false. So for example, if I say true equals empty string, it's going to say that that's not true, right? Because the word true, the capital T true, is not equal to the empty string, right? They're not the same. However, let's say I say s equals empty string, and I say if s, print s, else, print truthiness. It prints truthiness. The reason for that is because empty string is truthy, quote unquote, in that if it's something, or empty string is false-ish, and then some non-empty string is true. So like, even though this will come out to be false, you can still use it like it's a Boolean. Many other objects have this property, which we will potentially highlight some more of them. But that is the type of thing that ultimately you can kind of just look up. It's not really that relevant, but it's kind of fun to mess around with if you get more into Python. All right. Hopefully that is a quick introduction to strings well, oh, I'm not sure if I missed this. How do you run the if statement again after changing the value of the variable? Oh, okay, yes, we'll answer both those questions. So how do you run the if statement again after changing the value of the variable? What you would just have to do in the interpreter is just retype everything, unfortunately. You have to retype it all, which is mildly annoying, but it's not the worst. In Jupyter, you can just rerun you just use the run button to rerun everything, or rerun the cell you want. What does this statement if S means? Yes, so S, since that was an object, most objects in Python have something called truthiness, quote unquote, where the idea behind truthiness is that you can use them as conditions in if statements or loops or whatever you want, and it will still run as if you put an if statement, but it kind of, it basically it runs as if you put it in an if statement. If, like, let's say S was that string, the empty string, if S is the same as saying if S not equals the empty string, right? That's just, yeah, you don't, it's kind of one of those things where, like, if you know about the truthiness of certain objects, you can kind of make your code shorter. But if you don't, like, let's say you put if S not equals empty string, or you explicitly check some stuff, it's not going to be wrong. It's just kind of like, yeah, it's not wrong. It's just a preference type thing. That makes sense. Great. All right, next, we're going to move on to a new structure in Python, one of the most useful ever created. They're called lists. Ooh. So list is a built-in type in Python. You can access it by using the word list, like so, or just by using empty brackets by itself. So let's say my list equals brackets. Great. So now we can say type of my list, and we get back the list. So all those are different ways to define a condition. Yes, for if statements, those are just different ways of defining them. How do you clear? I was just closing, like exiting the interpreter and then restarting just to clear everything out. Cool. All right, so lists. Lists are a very useful type of Python. They function as generic catch-all data structures when you need some structure. The way they work is that you can store whatever you want of whatever type you want in your list and access them kind of like you access parts of a string. A lot of functions that worked on strings, like len and the slicing stuff, work on lists too. So let's define a list called colors. Let's put some colors in it. So let's say red, green, and blue. So that's how you define a list literal, in the sense that this list object right here, right, is defined here. So if I say colors or print colors, either way, you get back the list, right? So now, lists, like strings, are accessed the same way. So colors at 0 is red, colors at 1 is green, and at 2 is blue, right? Just like strings. A difference between lists and strings, though, is that lists can be, or rather, I should just say, lists are not immutable, right? So, as an example, we have colors, right? Great. Someone throw out, what's your favorite color? Just throw out a favorite color. Blue. We already have blue. Pink. Great. So if we say colors dot append, which adds a new thing, and we say pink, and I think I saw purple too, so let's do that again. Purple. If we did this with a string, you'd remember that it would give you back a new string, right? But the original string is unmodified. If we print colors now, it's modified. It has changed, right? So this just means that our list here can be modified. It's not immutable, right? Cool. Kind of like before, the len function tells you how many items there are, which now there's 5, right? So now an important thing to note is that the equal sign does not make a copy of your list. It actually just makes another variable that points to the same exact list. And a way you can check that is by using the word is. So equals equals, like let's say 3 is 3, it's going to say true. Same with 3 equals equals 3. However, let's say I have colors here, and I say colors 2 equals colors, right? Now, if I say colors 2 equals colors, it says yes. That just means it's checking. Can you append a certain index? No, we can insert a certain index. We'll actually talk about that function in a bit. But colors 2 is colors will give me back true, because they are pointing to the same variable. So if you want to check if things, like if two variables point to the same thing, you use is. If you want to make sure that they are the same content, you use equals equals. For people from Java, if you've used to Java, is kind of like saying equals equals, and then equals equals is like dot equals for the Java people. If that didn't make any sense, it doesn't matter to you. Then don't worry about it. Can you make a list with limited number of indices? Actually, no. Lists grow as you need. They will resize and grow and shrink as you insert items. They can't be fixed with, which is a little interesting. That lists by default are growable. They can't be set to a certain size. Or at least not like in a way that doesn't involve you kind of setting the size. Like, how do you take away from a list? Yeah, we'll get there in a bit. All right, so before we get to some of these great questions, one thing we need to talk about is loops. Specifically, we're going to talk about for loops here. For those of you who are coming from a background in a lot of other languages, you're probably used to saying loops like this. For int I equals 0, I is less than some, like, let's say Java, something like this, right? You're probably used to stuff like this, and then you do some task. Python loops, in general, Python for loop are much simpler. You have a construct called for in loops. The way it works is that you have the word for, then you make a variable name. I'm going to say colors or color in, and then after the in, you put some list or something that can be iterated through, like a string or a list. Or so we'll say colors for color in colors, put a colon, press enter, press tab. Now you can start doing some stuff. Like we'll say print color, and then we press enter. And you'll see that says for color and color, print color, and then it does that. Right? It goes through your list and it prints everything. Right? Slightly different than a for loop than what you're used to. If you want the for loop like the version that you're used to in other languages, you could say for num in, then a function called range, which gives you a range of numbers. And then we want the length of colors as the limit. And then we could say print colors at num, which you'll see that that's the same thing as before, right? But it's a little bit clunkier, right? All right. Cool. The next construct is searching in a list. The word in can be used for this as well. So let's make a new list. Colors equals red, green, blue. We can say, let's say pink in colors. We get back false, right? It looks through your list and tries to see if it can find it. If it can't, it says false. But we can say red in colors, and we get back true, right? So the in lets you search. That's why you can say for something in something, and you'll loop through, right? That's an easy way to tell if something appears. In can also be used in other collections as well, in other objects as well, which is very nice. All right. For in also works on strings. So let's take our string that we used earlier. This string, we can say for ch for character in s, print character, and it will print all of them separately, right? For a list, like for your loop, it doesn't matter what you name this first thing. You can call it whatever you want, providing it's not a reserved word. So you can't say for str, right? That's reserved, or int, or other reserved words. But you can kind of put whatever you want, and it will just work, right? So we talked about range, but to get into more detail about how range works a little bit. Oops, wrong version of Python. The range function, if we open up the page for it, it gives you, there's a couple options, right? Stop and start, stop, step. It gives you a sequence of numbers. So for instance, let's say I have for num in range 10, print num. This is going to start from 0 and print up to 10, not including. Right, so print up to 9. We can also give it an explicit starting point. So like for num in range -1 to 10, print num, and we get starting at -1, right? You can also give it a you can also give it a step, which can be something like this, or num in range 2 to 2048 in steps of let's say in steps of 10, print num. And you'll see that it goes and it prints all of the numbers between that range in steps of 10. Right? So perhaps a more practical version would be for num in range, let's say starting at 10, ending at -1, going in steps of -1. So it's going to go backwards, right? Print num, and we get back the numbers going from 10 to 0 backwards. Right? So range, you either can give it just one number, which if you give it one number, it starts at 0 and goes to there. If you give it 2, it starts at the first and goes to the second. If you give it 3, it starts at the first, goes to the second, using the third number of steps, whatever that may be.
Could you say that again? Sorry.
Yes. So I'll actually just show you in, this might help a bit to see it, I think. So let me restart this, make it cleaner. So the range function, if you give it one argument, let's say for num in range 11, print num, it will start at 0 and go up to the number you specify, but not including it. So we said 11, so it goes to 10, right? If we say for num in range, giving it two numbers, it starts at the first number and then goes to the second, like so. Right? If we give it three numbers for num in range 10, -1, -1, it starts at the first, goes to the second, but it uses the third number as how many steps, like how big each step should be. So if we say -1 steps, then it goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Right? So it goes backwards. All right. So the next thing would be to talk a little bit about a different type of loop. There's another type of loop you can use. They're called while loops. The idea behind a while loop is that in a while loop, it will run while some condition is true. So the way that that basically works is, let's say we have, I don't know, num equals -2. While num is less than 15, let's say we print num, and then we do num plus or equals num plus 3. So we'll add 3 to num, and we keep it going. And then you'll see that this loop, while num is 15, or less than 15, right? It starts at -2. It prints to -2. It adds 3 to it. It checks, prints that value, adds 3, checks, and so on. It keeps doing this until it's no longer true, and then it stops. So for loops let you loop through something, right? You loop through a range of stuff you know. A while loop lets you loop while something is true, meaning you don't necessarily know how big it is, right? So the ideas are they're similar, but for you can use if you know what you want to loop through. While is what you use if you want to go for some amount of time that you may not know. All right. So now let's get into some list functions, some functions that you'll see that exist on lists. All right. So we already talked about red, green, blue. We already talked about one of them. We talked about append, which lets you add something. We talked about append, which lets you add a color to your list. How to get out an infinite loop. Yes, you'll just have to quit. I would recommend you, press Control and C on your keyboard at the same time. That should kill it off. On Windows, you might have to do Control Z, I think. But yes, you can put infinite loops by just typing something like while true or while 1 equals 1 or something like that. All right, so we talked about append, which was add an element to the end of your list, right? Notice that append does not create a new list. It only adds it to your existing list. So like colors.append by violet, it changes colors, right? It doesn't give you a new list. Another one is insert. Let's say we say colors.insert at index 1, insert orange.
I have a question.
Right. Yes, what up?
Why is it when you put color.append violet, it only changed the last color to violet, not the first or the second one?
Right, so append will add a new element to the very end of the list. It just adds on a new one. Insert is what you can use to change a specific index. So colors.insert 1, orange, if we print colors now, index 1 has an orange. Or if we say colors dot insert at index 2, yellow, and then we print colors, you'll see that we've added to a specific spot, right? Which is nice. Lets you go to, that's how you can specifically put something in a specific spot. Now we can have let's say we have another list called more colors, and we put purple and pink in here. There's a function called extend, so colors.extend. You give it another list, and what it does is it will take your original list and add in the new stuff, right? So you had added purple, pink to the original list. Great. Now for some of the questions, like one question we had, I think that was how do you take away from a list? The easiest way to do that is to use pop. So if you say colors.pop and you don't put anything, it takes out the last element. So you see that it printed it, and if you look at colors now, it doesn't have that element anymore. You can also say colors.pop at a specific spot, let's say 0. And it takes out the first element, right? So it's basically the opposite of append. All right. Another thing you can use is index, which will search for the first instance of a given element and return the index of it. So colors.index of orange should say 0, but colors.index of red will be an error because red's not there. If you want to avoid that error, what you can do is use in, like we said earlier. Red in colors doesn't have an error. All right. 2 more functions we will talk about are remove and sort. Remove list, or say colors.remove orange, will now look for orange and take it out of our list. But if you try running it on something that doesn't have it, you get an error, right? You notice that orange isn't in our list anymore, so when we try to run it, we get an error. And then sort does what you think it does. It sorts your list. So if you have something sortable, like in some way, you can sort it using sort. In other ways, you can use pop, or you can use sorted, but we're not going to get into that. Last function we'll talk about with lists is reverse. So colors.reverse does what you think it does, and it flips the order. All right. Similarly, like with remember, like with string slices, same thing works here. We can say colors from 1 to the end, or from 1 to -1, or 0 to 3, just like before. All right. Cool. All right. So now we're gonna. There's more stuff here. Is there a replace for lists? That is a great question, and actually, that will be a nice segue into the next thing we're going to talk about, which is looking stuff up in libraries. So Python, one thing that's beautiful about this language is that if there's something you want to do, chances are somebody's done it already, which means that all you have to do is know what to look for, and you can probably find something that does what you want. So to answer your question of is there a replace option, what we can do is first start with the official documentation. So we type in Python 3 list. That should give us this structure. We go to this website. We can start checking if there's functions here that help. And it doesn't look like, at least from the documentation, it doesn't look like there's any way of replacing an element in a list, like directly, at least. There's no replace direct thing, unfortunately. But you can make your own replace by using index. But if you find, like, you could do something like this, I guess. Let's say we wanted to replace purple with pink. We could say colors dot insert, and then the index we want would be colors dot index of purple with pink. Oh, whoops, forgot a quote mark. And by doing that, we basically have done like a sort of replace, kinda, except we'd also have to follow that up with like a colors dot remove purple to make it act like a replace. So it's not quite a true replace, but you can kind of make one in that sense, but not like a true replacement type thing.
I have a question.
Yeah, what's up?
If you type a line of code and you accidentally like just forget one of the apostrophes or something, how do you quickly like rewrite everything that you wrote and then just fix the mistake instead of having to type out everything again?
Yeah, so in the interpreter, you can just press the up arrow, like the up arrow on your keyboard, and it will, and you can just press as many times as you want. It'll just keep going back through all the commands you've typed.
Oh, right.
So that way you can replace part of it if you mess something up. All right. So the next, I guess the next thing is functions, and then we'll move on from functions to libraries and pip, and then where to go from there. And then we can answer questions. But all right, first, functions. So all this stuff we've been doing so far has been just in individual lines of code, right? The next thing that we do that makes the most amount of sense to do is to figure out how to take our lines of code individually and turn them into functions that we can call. That way we don't have to rewrite the same thing. So how about we come up with a function that every time you say hi to it, it responds with hi. But if you say hello there, it responds with something else. So what we can do is we can define a function. The way you do that is you use the keyword def. And then we say the function name, say hello. We want our function to take in a string argument. So we can say s is our string. And we put a colon and press enter. Now we can press tab, and then we can start typing our function. So what we'll do is say if s is equal to hello there, then our function will respond with General Kenobi, you are a bold one. But if you say anything else, it will say print let's say it just prints your message back to you. Whatever you tell it, it prints back to you. Great. We press enter twice to make it stop, and you can see that say hello exists, right? So now we can run it by saying say hello, and we say hi there, and it responds with hi there. Or if we say what's up, oh whoops, what's up, it'll say what's up. But if we say hello there, it will say that, right? We can make the functions that are more complex or do whatever we want. The general idea with a function is that you use the word def, then the function name. Then you put the number of arguments you want. They can call them whatever you want. A colon, and then you just write whatever stuff you wanted to do. Where this can be stuff that, like, let's say, chops a string into pieces and prints it one by one, or yeah, stuff like that. So let's actually do that. Let's say we make a function called chop, which takes in s, and then it will, let's say, return s.split, and we split on white space, right? So we just have our function which takes in a string and then returns to you a new thing. So we can say chop, this string will be chopped, right? And then it splits it up, which it's kind of exactly the same thing that split does, but you know. All right. So a key idea with functions, without diving too deep into like some of the theory or whatever, is that you want your functions to, in general, do one thing. You should name them in a way that it's kind of a good thing. It's good to name them so that you can kind of know what the function does just by reading it. And then it's useful for your functions, since Python doesn't have these types, it's useful for your functions, unlike what I did, to have names that kind of tell you what you're dealing with. So for example, if we said our say hello function, we could name this message. And then now it's a little bit more obvious. Like if I say something like this, right, and whatever else, I'm just going to stop it there. But you can see that by naming it message, it's a little bit more obvious what this line of code does, right? Where it says if message equals hello there. It's a lot less cryptic than if s equals this, because you don't necessarily know what s means, right? So that's a good point to remember, is that with Python, due to the fact that you don't know what things are, it's very useful to name things in a way such that you can read the variable name or read whatever it is and know what it is from the name, because you won't have a type to be able to tell you. Any questions so far? Is there a way to have automatic tab? Automatic tabs. Not in the interpreter, but you can set up your environments if you want to set up like whatever development environments you want in different ways to be able to set up automatic tabs, stuff like that. But by default, the interpreter is not going to let you have automatic tabs. All right, so we're going to finish up pretty soon. The last thing we're going to talk about is probably my favorite part about Python, which is the libraries. So what's nice with Python is that so many people use it, so many people have developed stuff for it and other things like that, that there are vibrant communities of different tasks that you could possibly want to do all in Python. So as an example, if you're really into data science, there's a whole bunch of libraries that you can use, like Pandas and NumPy and SciPy and TensorFlow and scikit-learn and a whole bunch more, which help you do data science stuff or machine learning stuff. If you're really into music, there's libraries for that, like for helping with editing like WAV files and other MP4s and stuff like that. If you like doing photo processing, there's stuff to help you display images in Python or deal with graphics. There's a whole bunch of stuff that exists. And the way that you interact with all this stuff is by using this command called pip. So I will show you what this is. Pip. Here it is. Pip. So you should already have pip installed. You can check by going in your terminal when you leave the interpreter. So and type which pip. You should get back some response, although you might have to type which pip3, right? So pip3, if I were to command pip3, oh, there's no help main page for it. Okay, well, the idea behind pip is that pip allows you to access this thing called PyPy, which is a very fun name, but it stands for the Python Package Index, right? The idea behind the Python Package Index is that if you want something that exists for Python, hopefully the people who are using it or created it, put it on PyPy, and you can install it using pip. So some examples of packages. The way you install things, you type pip3 install, and then the name of the package you want. Some packages I've installed, I will show you right now. Pip3 list. Actually, pip3 list less. Okay, so here's some of the packages I've installed over the years. I have Beautiful Soup, which lets you do HTML parsing. So if you like automatically parsing websites, that's your package for you. Billboard.py, which lets you do billboard chart data stuff. The cryptography package, a linter, some web dev stuff, so from web development, if you like to make websites. Packages, more stuff for websites. Jupyter, which for those of you who have been using Jupyter this entire time, there's a Jupyter package, which you already have installed if you've been running it through Anaconda. Some stuff for databases, for stress testing, for handling Markdown, for passwords, for a whole bunch of stuff. More cryptography, right? You have all these packages which you can install and more. These are just the ones I've installed. There's definitely more, right? And the idea is that you can use these packages to help you, or this is in terminal, by the way. You can use these packages to help you with tasks that you wouldn't be able to do otherwise. For example, I think a very common use for Python nowadays is to do data cleaning, data wrangling, right? To do things with data. So an example of a package that can help you with that is called, what's it called? I'm blanking on the name right now. One sec. Pandas. We can look it up, Pandas Python. And here it is. We can go to the documentation. And then you can see there's a whole bunch of stuff here, like with data frames and a whole bunch of information about how they work. And then more stuff about how this stuff works. And all this stuff, the idea behind it is it allows you to handle files very, very gracefully. So as a quick diversion for that, I will show you what I mean by this. So this is, I guess, something just to check out. You don't necessarily have to follow along on this part, but just as like a 108, I think has some. Or what about Pi machine learning? Okay, let me just find something I can use for this hands-on ML. LGD exercises. Yeah, okay, we can use this. Jupyter notebook. I'm just gonna fire up Jupyter real quick. Okay. So, I mentioned like we have this thing for data wrangling, this library called Pandas. I can show you a little bit of how it works here. So for those of you, so you see that we have some imports here, where you import your thing, you import your package that you want. The as lets you rename it, so that way you can use MP instead of using NumPy everywhere. Or you can import specific parts of some packages. All right. So one thing that's nice is like you can see here that like I did some stuff here, right? And I print a number. If we were to try to do this with just raw Python, if you're in Windows, yes. If you're in Windows, we can actually go back to that. I'll go back to that just in about a minute. But so yeah, you can see that this number here, the thing that got printed, all this stuff here is possible in just regular Python, right? This would be a lot harder. So the idea behind packages, the idea behind using packages is that you can make a lot of stuff that is normally very much involved a lot simpler, right? Now, for those of you who are using Windows for pip for Python, note not to worry. We can go to the pip website, pip for Windows, and find the Windows version. Here we go. And if you're using Windows, so pip should work on Unix, Linux, Mac OS, and Windows. What you may have to do is check how, for Windows, I think the thing you'd have to check is how Windows installed Python. So if you're using the official installation, you just have to see how to deal with the official installation from the website and how it works with pip. It's a little different for Windows compared to Mac OS, but still doable. All right. So next steps, where to go from here. Hopefully, even though it may have been a kind of a quick rundown, you should have seen, hopefully, the basics of some string stuff, a little bit of list stuff, some basic operations you can do with if statements, for loops, and while loops, and the basics of writing functions. With this, you should be able to, hopefully, if I were to show you some Python code, maybe not fully understand everything that's happening in it, but at least be able to read through it and understand parts of it, which is a good goal. It's a good place to start. If you really want to get into Python, what I'd recommend you do next is the official Python tutorial on their website is pretty good, but nothing beats getting the chance to just try building stuff. Go out and try writing some Python scripts that do some basic things. There's a lot of ways, a lot of things you can try out, a lot of libraries you can test out. And once you've worked on, if you're new to programming, some of the fundamentals of programming, as well as just some basic scripts, if your interest keeps going from there, you can learn more about the deeper features of Python, how it works, some of the bigger stuff in it, and it goes from there. For me personally, UCSD doesn't really teach Python in any programming classes. Unfortunately, I got interested once and decided to look into it, and it went from there. So I'd recommend that if you're into Python, or if you want to try out programming, do the same thing. Just give it a shot. You don't have to freak yourself out with anything big. Start small, and you'll grow from there. And I think Python is a language that hopefully you all grow to love as much as I like it as well. All right. I know it's kind of a brief rundown. There's only so much you can really talk about, and there's so much to cover in 2 hours. But if there's anything else you want to know about Python, or you want to find out, feel free to message me on Facebook. Am I allowed to say this, by the way? People running this, am I allowed to tell
Sure,
people to
absolutely.
message me if they want? Great. Okay, just making sure. I don't want to all right, I think this is my messenger link. All right, that should be my messenger link. If you have anything you want to talk about with Python, or want to learn about Python, or anything that you were looking into, or that you want me to cover, or whatever else, feel free to just message me. I'll respond as soon as I can. Which, truthfully, given the whole not having school thing, well, you know what I mean, I can respond pretty quick. But yeah, thanks for having me. Hope your quarters are all going pretty well, and I'll hopefully maybe see some of you guys around. All right, thanks. Oh, messenger link doesn't work. Whoops, hold on a sec. It's I messed it up. It's actually mir.com/t/mp complete. Nate. I think that's the link with the /t. Try that one.
All right, everyone, thanks for coming. We hope you had a really good time learning about Python. Many thanks to Nate for giving us such a great presentation. As he said, you can contact him via Messenger. If you have other questions, you can also contact me. Yeah, there's a lot of, Python's really, really cool. You can do a lot with it. So if you're really interested in it, I'd say go for it. If you haven't signed in yet, please go ahead and sign in. We'll post the recording on our website in a few days, and check out AIChE UCSD on Facebook for more events. We have some really cool things set up for you, and we're just working on the details. So they'll be up in a few days, or whenever they're available. So yeah, I hope you have a great night, and thanks for coming.